Hi, welcome to the new lesson of this module, and here I would like to share with you the evolution of data engineers in the organizations or generally in data teams. So to start, the first key moment is when we have been working with low-code tools, mostly in business intelligence teams on on-premise environments, and very often with custom frameworks or maybe third-party frameworks that were proprietary solutions. So you had to pay the service, you had to pay some training, and also consultants coming to your company. And that was a bit cumbersome and very hard to evolve for the companies, especially when we had more and more data to process. So remember Google, which is very popular search engine, they are processing a huge amounts of data. And I'm mentioning Google not by chance, because they had a very strong footprint on modern data engineering back in time with the MapReduce paper. So at that time in 24, Jeffrey Den and Sanjay Gramavat published a paper called I just have to take my notes, MapReduce Simplified Data Processing and Large Clusters. So the origin for this paper was their work on search engine indexation at Google, because the authors realized that, so they have already implemented the indexation 2 times, and before doing that for the third time, they realized that the code and the processing logic was very similar between all these attempts. So they decided to create a kind of general model, computing model, that will be able to handle increasing volume of data at Google and also in other places in the internet. In simple terms, they summarize this processing at scale to a very simple question. So let me just quote it. It was how to coordinate the work in a vast number of geographically distributed and individually unreliable computers. So they defined this model called MapReduce, but it was just something very abstract. It wasn't an implementation. The implementation came just only a few months later with the Hadoop MapReduce and more generally with Hadoop Stack. So the genesis for Hadoop MapReduce is that 2 programmers, Mike Caffarella and Doug Cutting, have been working at Natch in a very similar problem to Google, so in a search engine, and they decide, having problems to scale the solution they had on-premise, they decided to adapt the MapReduce model and create an open source library called Hadoop MapReduce. But this Hadoop MapReduce turned out to be only a single one of many components of something we called at the time Hadoop Stack. Among other components, we had a Yarn, which was a resource manager, so something that helped you to allocate resources to your job. We also had HDFS, which is a distributed file system to store a large amount of data replicated across different servers. And we also had later more data specialized tools like a Hive, that was a kind of data warehouse layer on top of HDFS. And we also have some other alternatives, data processing alternatives with tools like, for example, Pig. And it was also the time when we have started to talk about real-time problems, and also when first real-time frameworks like, for example, Apache Samza appeared. And it was also the moment when we had the first materialization of these 2 words, the batch and streaming words, in an architecture. And this architecture was called Lambda architecture. So I will detail this architecture later in this module, so do not worry about it. And let me pass to the next point, which is a kind of modernized Hadoop world with Apache Spark, Apache Kafka, Apache Parquet, so all projects from the Apache Software Foundation, and an alternative to Lambda architecture, which is called Kappa architecture, more oriented towards real-time processing, although it also have a capacity to process data in batch, so process data at rest. So just to introduce these tools, Apache Spark was created by Maitei Zaharia at the University of California at Berkeley, and it was a more performant alternative for Apache Hadoop MapReduce that was mostly based on files right on disk, whereas Apache Spark does have done and does currently still does a lot of computation in memory, which is obviously much faster to access and to process the data. Another tool is Apache Kafka, which was a streaming broker developed at the time at LinkedIn, and it happens that it's kind of reference for in streaming brokers world nowadays, even though there are modern alternatives that try to use a different architectural approach. But anyway, you will, I bet, at least as for 2022 and 2023, you will meet a lot of Apache Kafka architectures. And the last one is Apache Parquet, which is a columnar data store, columnar file format. Of course, before we had also Apache Orc, which was kind of alternative format, but Apache Parquet became very popular and had a lot of interesting optimizations like data skipping, and it happens that it turned out to be the first solution for data warehousing and data analytic purposes when it comes to storing this data as files. But fortunately or unfortunately, because data engineering, as you can see here, has a lot of kind of breaking points that creates a new momentum, and you, as a data engineer, your role is to follow all these key moments. So the next key moment is the cloud computing and serverless. So before, data engineers have been working a lot on premise, so the computers that were stored in your organizations, warehouses, and places, server rooms. And here the cloud computing consists of delegating this storage capacity to some third parties called cloud providers. And this is very nice because really, as a data engineer, you can focus on solving business problems, eventually defining some infrastructure, but still it's a code definition. You don't have to go down to plug some cables and connect the servers. You don't have to wait for your company to purchase new machines if you need to scale your workloads. It's very seamless and very reactive, and I think it's a great adaptation to the workloads we have nowadays, which are very variable, that can change from day to another. And in addition to that, we have these things called serverless, which is kind of cloud providers promise saying, don't worry, we have the scale, we scale your back in general, and you are just focused on write the code. So the serverless is more like abstraction, getting rid of all the worries of, oh, my pipeline will scale very well, or I have to think about when to scale and stuff like that. So generally here it's more like not thinking about these aspects and delegating them to the cloud providers. Of course, it's a very simplified definition, but anyway, I think that you understand the comparison with the server world. And the next question is what to expect next time. So it's very hard to predict. Maybe, so just to give some technical context, so far Hadoop Stack, Apache Kafka, Apache Spark are all based on the JVM technology, so Java or Scala language, which is very powerful because there are a lot of users, and the entry level is much more lower, so there is less technical requirements to use these tools than, for example, for C or for C++. However, we are observing right now a lot of new services and also new frameworks that try to use more memory effective languages, so to call C++, or even something which is quite new at the time I'm recording this video, which is the language we called Rust. So I don't have the silver bullet. I cannot predict what will happen next, but anyway, I'm sure that it still be exciting to be in the domain and to learn new things, of course, and of course use our past experiences for writing efficient pipelines, because fundamentals generally don't change very often. It's only the tool and all the creative stuff, like for example from changing on-premise to cloud computing. It may looks like some mindset changing, but still, if you are able to write reliable pipelines on premise, you should probably be able to do that on the cloud. And similarly, if you are able to write an efficient code in Apache Spark or other data processing tools that we have nowadays, you will probably be able to do that also for the C++ or Rust frameworks. Modulo, of course, all the language changes you have to assimilate as a data engineer. So enough talking, let's move on and see you in the next lesson.